Testing. Testing. Hello world, how's it going out there? Welcome to the stream. Alright, welcome to Coding a Roguelike in C. Let me catch you up with... Wow, we got some weird artifacts on this thing. Interesting. Oh, there we go. Weird. Okay, last stream we were working on our map generation and smart layout for hallways, and we managed to get most of the way done, but there were a couple really pernicious bugs lurking in the hallway layouts, and the problem was that with the generation code there were so many different code paths that most of the code paths were working as expected, and like I think one or two of them had small bugs in them. So it was drawing most of the hallways correctly, but occasionally we'd get a hallway that didn't, that just went off into nowhere, or we would get a hallway that didn't draw at all, and so we'd have an orphan room. So off stream, I basically threw in a bunch of printf statements and stepped through like a bunch of different maps, and was able to reproduce the problems and finally figure out what was going on. So if you check the latest commit to the GitHub, the repo is right there. You can see some of the changes that I made, but I guess basically we had like when we were comparing, we had a problem in our test code where we were testing to see if a cell was in a room. There was a problem in the comparison logic there due to some copy pasta, and the biggest problem was that I didn't account for the case where if we have a one segment hallway that has a horizontal and a vertical component, if that turn was happening inside of a room, and it was the same room that the segment started in, it wasn't handling that case properly. So we should have all that fixed up now, and let me just build and show you where we're at real quick. So here we go, here's our map. And I still have the shadow casting turned off so you can see the entire map at this point. But you can see that our hallways are much nicer. We don't have any Swiss cheese rooms that have like a million hallways going through them. So I'm pretty happy about that. I think it's good enough for now. Now the only tweak that I'd like to still do with the map generation at this point is I think that the rooms need to be a little bit bigger, because like if you see you know, I think that three cells either wide or tall is just a little too small. So let's see if we can adjust that. And that's going to be in our room generation code, which it should be in map generate. Oh, that's the other thing that I did. I did a bit of refactoring off of stream. I moved all the map code into its own file just to keep things more segmented and more easily categorized. So now game.c has all of our game object and entity component system stuff, the various components that we've defined, and then it has the functions that deal with manipulating game objects. And then right now it has level management in it, which may or may not get moved into its own file once we grow this a bit. So let's go to map generate. So here's where we're generating the random width and height. Right now we're generating room widths or rooms with width and height between 3 and 20. And 3 is a little too small. So let's bump this up to 5 and see what our maps look like.
Out here on my own, you
Building.
left me broken and alone.
Well, that's definitely a lot cleaner.
Stomach turning at the thought of any.
All right, should we turn on the shadow casting and see what this looks like? I think we should. Let's give it the full effect. So that is here, I think. Let's build this. All right, so now we're in. Cool. All right, I like that. Now, I wonder if perhaps we should cast or change our field of vision to be a little bit wider, because right now this is pretty much the extent of it. So it's like 1, 2, it's like 9. I think we cast it 4 cells in either direction, but like you can't even see the other side of like fairly decent sized rooms, which is a little weird. Like look at this, you just got nothing. This is a really interesting map. Whoa. Oh, this room is massive. Okay. Yeah, so I like this. Let's up the field of view and see what we can see now. I don't remember even where that function is. It's probably, it must be in our, oh, wait, we have a whole separate file. Yes, we do. Okay. So our field of view distance right now is 5. Let's just up it to 10 and see what. Okay, so now we get this whole room is illuminated. It's a decent sized room, so that makes sense. And now I like this a lot better. Yeah. I think that's cool. Yep, so at least you can get a little bit of visibility down the hallway before. Okay, I like this. Wow, these are some really interesting maps that are coming out now. And then in a massive room like this, you get, wow, a massive room. You get some interesting. Wow. Cool. Alright, yeah, I think this is the way to go. I'm satisfied with that for now. And, I mean, that's the cool thing about this. We can tweak it as we go, or if we decide that that we want to mix it up, we can do that. Alright, so the next, let's see, where's my to-do list? Oh, we need to add floors to our map. Let's do that before we X this box here. Alright, so we need to add floors. So let's go into our map gen function. And so when we'll need to adjust carve room and carve hallways. And basically, oh, we don't need to adjust these actually. Everything here is false. And we generate, where do we generate our walls? Excuse me. Right here, we do wall add. So what we're gonna do, otherwise, because if it's not a wall, it's going to be a floor, or open space. So our wall objects are game objects. So our floor similar. do game object create, which will just create our vanilla game object, generate an ID for it. It's going to have a position, just like our walls. And, oh, I'm going to use this. I'm going to use this cool trick that I learned now that's a newer function of C. So it's going to be, where's our position defined? We've got object ID X and Y. So object ID, that jumped back to the wrong place. So I'm going to do floor ID, and then you can do this dot X equals X and dot Y equals to Y. So you can use like named, you can name the value, the data item in the struct that you're setting. Which leads to a readable code. All right, and then we're going to add that component. That'll be position. I'm going to add floor pause. Send in a pointer to that. And then visibility, we're not going to add. Wait a minute, we are going to add it because it's visible. Yeah, we don't add a physical component. So I guess we could add a physical. I guess we do add a physical component. We just say that it's non-blocking. Alright, so I'm going to copy these. Do a little copy pasta here, and then we just make sure that we don't get sloppy. And we're going to use the standard period glyph. And then we've got a black background here. What foreground should we use for this? I feel like the floor should be darker than walls and almost you know, not very visually striking. It should just allows us to see that there's like a cell there that can be that the avatar can move into, but other than that, we don't really want to call attention to it. Alright, finally we'll add the physical component to our floor. I can't type on this keyboard. And then, oh, so let's set these other, I think this is glyph. And then this is called, is it FG? FG color, BG color. And then has been seen, which if I'm not setting it, will automatically be set to false, so that's perfect. FG color, BG. Oh, ASCII char. No, glyph. Glyph, FG color, BG color. And then for our physical component, it's blocks, object ID. It's blocks movement and blocks site. I need to get a new keyboard. I can't type on this laptop keyboard. And blocks movement is going to be false because it's floor. And blocks site is also false. Blocks movement, blocks site, yep. Alright, so let's let me find a color. Just gonna go out here to find a decent color. We want like kind of like a light. Or maybe we want a very dark gray, so it's almost blends in with the black. Oh, this isn't. These are his latest favorite colors. That's good. It's something like a. 3C. So we can give that a try, and then maybe even play with the alpha value to fade it out a little bit if we feel like that's something that we want to do. Alright, so that should add floors. And see, I almost copy-pasted it. Always gotta remember to fix that stuff up. Whenever you copy-paste, beware. Okay, so we've got our floor add, which we're gonna call for cells that are not carved out, or for cells that are carved out. And the rest will be walls. Okay, so it built. Okay, and so it's drawing our floor, but it's not drawing our hero anymore. Oh, I like that. Look at that. You can see how the field of view is rounded. That's perfect. That's exciting to see. That we couldn't really get a sense of until we had those floor. Yeah, I like it. Okay. So where did our little hero go? Let's figure this out. that's going to be in probably, where do we do our rendering? Render screen. So we've got two. The problem is we've got two visible components occupying the same cell, and so basically what I think is happening is that it will find the player's game object first, render it, and then when it's going through the map rendering, since all that stuff was added, we just move sequentially through our object array. The map stuff that was added later will be drawn over. So I wonder if we need the concept of layering. Alternatively, I suppose we could just draw a transparent background. But that would still draw, so that would still, we would have our avatar, but I think it would appear above. Well, let's give it a try. If we, where do we add our player? Okay, he's right here. If we made the background transparent, so cleared out the alpha, and then we went back to map and add, what's my add? Oh, it's in game. I made these guys transparent. Background. Let's see. Yep, now we got both. So that's kind of a cheat because the dot is actually on top of the @ symbol. And so we do need the concept of layers. Because we, in the case of our hero, we always want the hero to be drawn last and on top of everything. I can see if so we could have the concept of like a Z order. Just trying to think about how the rendering code would then work. I wonder how that would work. So we're looping through all of our game objects, and then if it has a visibility component, then we grab that. And then render it based on oh yeah, I do the faded color. Okay, cool, yeah, I'm just fading that out. I'm just familiarizing myself with the logic for how we draw things that have been seen but are not currently visible. So what we would need, we get the position right here. We would need to look for other things at that position. Just seems we would need to look for other visible objects at that particular X and Y coordinate, and then examine the Z order or the layer number for each of those. And draw them in order. Seems really, I don't know how you would get I don't know, looking for other objects at the same position, that seems really inefficient. I don't know how you would do that in an efficient manner. Well, without altering. I don't think we can do it in an efficient manner with our current data structure for game objects, but maybe this would perhaps this is a good reason to accept that, refactor those data structures, which were kind of placeholders to begin with, because right now we're doing just a pre-allocated series of arrays. And I'm not happy with this. One, because we're defining the size and our maximum number of objects, and I'd rather have those data structures use only the memory that they need, and also be able to grow to unknown sizes that are bigger than 10,000 Maybe I will make a note and think on that, and then we can keep moving. I'm gonna make a note. It's my to-do list. I'm gonna say add layering of visible objects in same cell. Proper layering. I'll put that, yeah. That seems like a good one. All right. So up next is monsters, according to my list here. So the first thing that we need to do is kind of figure out what type of components we need for our monster. So obviously we're going to need position. We're going to need visibility component. We're going to need a physical component. But now so now we start getting into the mechanics of like movement, or having an AI-driven game object. So we're going to have something I guess movement, it's not. I'm trying. How do we want this to work? So in our game loop, we process events. We're going to process all of our players' events. And then after we process the input, we okay, this calculates our new position for our player, so this actually captures the movement. We check to see if we can move, and we add the new position if that was a legal move. So what we want to do is something like this for our creatures. So we want to be able to say, for every game object that moves itself or can move itself, we want to ask that to update its movement, I guess. So we can do that after, we can do that before we calculate our field of view, because I don't know that we're going to have monsters that block sight. I guess we could have really large monsters that block sight, so we would want to move them before we recalculate our field of view. So this would be a place where we would call a system, in our entity component system. So we would have a movement system that would, essentially it's going to loop through the game objects that have a movement component and determine whether to move them. That seems like a reasonable thing to do. I'm not sure how we would factor some of that stuff. We could have I guess we could just call it movement update. Yep. That's not... game object management. We got our game objects, we got level management. This is going to be... So I guess it would be for each game object that has the ability to move. Maybe that's what we can do. We can do, like movement can have like a movement speed. Well, first we need, of course, our object ID. Man, my typing is on point tonight. And maybe we have a speed, so that would indicate how many tiles they can move a turn. So we could have super fast monsters that move 2 or 3 tiles in a given turn, maybe some flying creature. And then we could have slower monsters like a slime or slug or something like that, and maybe it moves every other turn. That seems good. So then, how would we represent? I was thinking about having it move like half a cell, yeah, but then we need to make that a float instead of an integer. How do we want to represent speed? Let's see. Maybe we don't worry about super slow monsters at this point. Or we could have movement, we could have speed and distance. I guess it would be distance and frequency. That's an interesting. So well, you could call this speed. And then we could also have one that's frequency. So you could have it how often the creature moves. So if it's 1, then it moves every turn. If it's 2, then it moves every 2 ticks or every other tick. If it's 3, then it would move every third. So we would need, and then we would need turns, ticks, till next move. This is how many spaces the object moves when it moves. Or I guess this is can move. And then this would be the countdown. That seems good. So that tells us about the properties of a movement when it happens, but it doesn't tell us about like what direction to move or what if it has a potential target. So I think we definitely want a movement target. But maybe not yet. Maybe we do a two-pass system where the first pass determines all of the targets or the destinations that things want to move to, and then we have an actual phase where the movement occurs. I like this song. This song is funky. Alright, so we have a movement component. So we're going to need an array to hold those, all of our movement components. We'll just go through the motions of initializing all this stuff now because I'm going to need a where do we define these? Oh. Whoa, I already had comp movement. That's scary. Omniscient. Apparently I also have health, so that will come into play as well. So movement. So essentially I'm copying stuff here. So this is the data that's passed in up here. Data. So I pass in the component type. I pass in the object that we're adding the component to, and then so this is the pointer to the data. And what we're doing is we are copying. We're not copying the data, so we're copying a pointer to the data into the... No, in this case it is actually copying the data because we're copying the struct elements, so... Let's see. Speed, frequency, and ticks until next move. We're going to do set the objects, the component array on the object to our component, because each object contains an array of all of its components, and each component in turn will point back to its related object. Okay. I think that's all the boilerplate stuff that we need for our adding a new component to our system. So we're going to do a movement update here.
You can be the stars, you can be the stars for me.
Base it on this.
Like the sky so I can see. Tell me something I don't know. Take me where I never go. I wanna know what it'd be like to disappear for a night.
So what we're going to do, we're going to loop through all of our game objects, and in this case, if we have a movement component, So in the case of our movement, what are we going to want? We're definitely going to want the concept of a destination.
Waste your nights in bars, but save the last drink for me. Untouchable and shining fire, you scatter like the galaxies. You call me up when it gets late again, like I'm supposed to know where you've been. Oh, but it doesn't work that way. No matter what you say, I want you until the end. You can be the stars, you can be the stars for me.
So the movement update, we actually want to apply the movement. So it is going to move, and then if it is moving, so new position based on destination and speed. So we are going to want to grab the position.
Close your eyes. They just haven't seen it.
So we'll see if the object is going to move. So we do that by we will grab the movement component. So we want to grab the movement component. Actually, the array is so we'll do and if that's less than or equal to 0, we're going to be moving. Oops. And what we also want to do is set equal to the frequency, because we basically want to reset our tick counter. Alright, so we're going to grab our position so that we can update it. So, jump back to my game loops. How am I updating the position for the... Oh, because I need to check if they can move. Ah. Yep. So I want to, once I calculate the new position, be able to update it. This is going to be because we want our mission to be initialized with the current values for the object's position. And then we're going to manipulate it. So and then we need to say if can be moved to. And then we'll move, so we add the component, and basically add will do the update if, and we want, in this case, we don't want to add it to that object. We want I think we want that. Gotta watch that copy pasta. Passing a pointer to that object, which I believe is what. Yep, takes a pointer. Alright, so alright. I think my brain is fried for tonight. I'm tired, so I think I'm gonna think about how we're gonna determine. Oh, let me go ahead and add this while I'm thinking about it. I think we're going to want I'd like this to be like, how are we going to represent if they don't currently have a destination? Well, maybe. Maybe that's a different system. I'm gonna have to think on this for a bit. I think we're still gonna need the destination, but what do we need a flag that says has destination? Maybe I break it out into... I don't think I'm going to break it out into two components. So there's a concept of the properties of movement, like speed, frequency, and blah, blah, and then there's the whole like target concept. Which you may or may not want to move to. Like if your target is 5 squares away and you can shoot 5 squares, like you don't necessarily want to move to that target. Let me leave it like this and think on it a bit. So I'm going to sleep on it and come back to it next stream. But I think we made some good progress tonight. We finished our map beautification. I do have that to do to go back and figure out how to properly layer objects that are in the same cell. How do we render them properly so that there's a layering or a Z order? So I got to think about that as well. But I think it was productive. We have a pretty cool looking map, and it looks really good with the shadow casting. Now, casting its field of vision a little bit further than we originally had it. So I think I'm satisfied with how things are going so far. And next stream we will get to more monster building and build out our movement subsystem. And then from there, we need to, then we'll start getting into combat and things running into each other to attack and health and all of that cool stuff. So yeah, I'm going to end it here, and thank you for watching. If you want to be notified the next time that I stream, be sure to hit that follow button, and you'll get stream notifications. If you want to catch up on past streams, the archives are on YouTube. If you have any questions or comments, hit me up at PDCodes on Twitter, and I'll be committing the latest source code changes to the GitHub repo. You can check that out and play with the code at home. So thanks for watching tonight, and I'll catch you again soon.